Hello friends, our team name is Froza Blazers. We are here to discuss on information theory concept that is DES, Data Encryption Standard. Our team members are विश्वजित महेश पावदेनकर, तन्मय तुकाराम कुंभार, अथर्व अशोक गव्हाणे. DES, Data Encryption Standard, is a symmetric key algorithm for the encryption of electronic data. It was developed in the early 1970s by IBM and adopted as a standard. DES uses a 56-bit key to encrypt and decrypt data, providing a level of security suitable for most purposes at the time it was adopted. However, due to advance in computing power, DES is now considered too vulnerable to brute force attack. There are some key features and characteristics of DES. For example, block size. DES operates on 64-bit blocks for plaintext. Its key size, the key length for DES is 56-bit, and the Festal structure. DES uses a Festal network with 16 rounds of encryption. There are some structural components of DES. Example, Festal network, subkey generation, and S&P boxes.
Festal network, the data encryption standard DES algorithm is based on the Festal network structure, which uses multiple rounds of processing to encrypt or decrypt data. It involves dividing the input block into two halves, and each half passes through a complex set of operations, including permutation, substitution, and key mixing. The output of each round is combined with the other half, and this process is repeated for multiple rounds to achieve encryption or decryption. Subkeys generation. DES algorithm involves the generation of subkeys from the main encryption or decryption key. These subkeys are used in each round of the Festal network to perform complex operations, ensuring the security and randomness of the encryption process. The key scheduled algorithm generates 16 subkeys, each 48 bits long, through a series of permutation and rotation operations on the main key. S and P boxes. The DES algorithm includes S boxes and P boxes, which are used for substitution and permutation operations. The S boxes perform nonlinear substitutions on the specific bit patterns, introducing confusion to the encrypted data. On the other hand, P boxes rearrange the bits in a specified order, adding diffusion to the encrypted output. These components contribute to the cryptographic strength of the DES algorithm. S block. The role of the S boxes in the function f cipher function is that the substitution includes a group of 8 S boxes, each of which takes 6 bits as input and creates 4 bits as follows. The first and last bits of the input box Si form a 2-bit binary number to choose one of 4 substitutions represented by the 4 rows in the table for Si. The middle 4 bits choose one of the 16 columns. The decimal value in the cell chosen by the row and column is then transformed to its 4-bit description to make the output. For instance, in S1 for input 011001, the row is 01 and the column is 1100. The P boxes are permutation boxes which are usually one of the main components of a modern block cipher. They are also known as D boxes or diffusion boxes. P boxes are used in the block cipher called the data encryption standard, commonly known as DES in cryptography. This P box helps in adding confusion and diffusion so as to make the attacker difficult to decrypt the message hidden. The input block bits are permuted and hence the confidentiality of the message is preserved. This helps in securing the message more efficiently. There are three types of P boxes. Types first straight P box, second expansion P box, and third one is compression P box. Encryption process in DES, initial permutation IP. The first step in the encryption process of DES is the initial permutation, which rearranges the 64-bit plain text based on a fixed table. This step serves to distribute the bits to prepare for further processing. Steps for IP: key transformation, expansion permutation, S block permutation, P block permutation, XOR, and swap.
16 rounds of Western network. After the initial, the plain text undergoes 16 rounds of Western network structure, where the text is divided into left and right halves. Final permutation. Following the 16 rounds of processing, the left and right halves are swapped and final permutation is applied to obtain the 64-bit ciphertext, which is the output of encryption process. Decryption process in DES. The decryption process in data encryption standard DES involves the reversal of encryption process, where the ciphertext is transformed back into the original plain text using the same algorithm and key. This process begins with the ciphertext block. After the initial permutation, the 64-bit ciphertext block is divided into two 32-bit halves. The right half undergoes expansion and permutation, followed by XOR operation with the corresponding subkey. The result is then subjected to substitution boxes and permutation. Finally, the output of the 16th round is subjected to a final permutation, which effectively reverses the initial permutation used in the encryption process. The resulting 64-bit block represents the plain text message, thereby strength and weaknesses of DES. Strength. Data encryption standard was the first encryption algorithm adopted by the US government and was widely used for many years due to its pioneering role in securing data. Weaknesses: DES has the alternative small key length of 56-bit, which makes it vulnerable to brute force attacks in today's computing world. DES modes of operation. There are various modes of operation such as ECB, CBC, OFB, CTR. Data encryption standard has several modes of operations, each designed to address different encryption requirements and security considerations. DES key in management and key schedule. The data encryption standard, key management, and key schedule involve critical process of ensuring the security and integrity of encrypted data. Key generation is the initial step where unique keys are created from encryption and decryption operations. Key distribution follows involve the secure of keys to authorized parties. There are several alternatives in DES in current state, such as cryptography, digital signature, cryptography, blockchain technology. Blockchain technology, with its decentralized and tamper-resistant nature, presents an alternative approach to data security.